Hi everyone. So in this video we will talk about cost and benefit analysis. Here is a brief review of the last video. In the last video we introduced two types of valuation method. The first one is called revealed preference, and the second one is called stated preference. So for the first one, we infer the value people place on a natural resource by examining behavior in the market for related goods. And for the second one, we just ask people, often directly, how much they value a resource. So through this method, we want to know how much individuals would be willing to pay or willing to accept for a small change in environmental quality. So these are two methods. So for the first one, the revealed preference method, it is observable because individuals involve actual behavior, but it is indirect because we infer value of environmental good or service rather than estimated directly. So there will be 4 different revealed preference methods. The first one we call it averting expenditures. It measures how much do you spend to reduce damage. For example, how much do you spend to reduce the pollution? How much do you spend to reduce the water pollution, the air pollution? And the second one, we call it travel cost method. We use it to measure how much people spend to visit a resource. It depends on the number of trips and the cost of the per trip. The third one is called hedonic property values. It measures how much do you pay for housing in different locations. And the property value depends on so many different kinds of factors. For example, the number of rooms with parking lot or not, and the neighborhood, crime rate, school quality, also the environment. So it depends on so many kinds of aspects. The last one is called hedonic wage method. It measures how much income do you need to do a particular job. Or we say it measures the value of a statistical life. And then we jumped to contingent valuation. It is a survey method to decide the willingness to pay or the willingness to accept for an environmental good by directly asking people what their willingness to pay is in a hypothetical situation. So in this video, we will first talk about cost and benefit analysis. What is cost-benefit analysis? Then we jumped to present value and future value. First, cost and benefit analysis. We first need the definition of cost and benefit respectively. So total benefits are measured as the area under the demand curve, as we mentioned in the last videos. And the demand curve is defined as the marginal benefits or willingness to pay for all individuals. Total costs are measured by the area under the supply curve, and the supply curve is defined as marginal costs or willingness to accept. Environment. So for this course, environmental service or resource services have costs even where there is no human input, but the environmental service or environmental good itself has costs. So the cost and benefit analysis, we need to compare the costs and benefits of public good projects or of environmental goods to decide if they should be undertaken. For example, for pollution, we need to compare costs of pollution damage and benefits from the activity creating the pollution. Then we would know if it is worth to pollute. That's for pollution. That's the cost and benefit analysis for pollution. Even though pollution is bad, but the activity creating the pollution should be good because it provides us so many products, it provides producers some profits, it provides customers some products. So the activity itself is good for human in some aspects. So back to our demand and cost curve. In this slide, we see that the total benefits are the area under the marginal benefit curve, and the total costs are the area under the marginal costs curve. From the perspective of cost and benefit analysis, so we should preserve river until the net benefits are positive. So what does that mean? If the net benefits are positive, if the difference of total benefits and total costs are positive, then we should go ahead to preserve river. So here I have two different questions. First, should a 4-mile stretch be preserved? And then, should a 6-mile stretch be preserved? Let's see the 4-mile case first. For the 4-mile case, we can see here the total benefit is the area ABCK, and the total costs are the area enclosed by ECFK, right? So the difference would be exactly ABEF. So that's for 4-mile stretch. That's for 4-mile stretch. For a 6-mile stretch, the total benefits would be ACGH. Then the minus the total costs, the area on the marginal cost curve, ECIH. So the area would be exactly AEO minus small triangle OIG. So we can say from these two analyses, we should preserve 4-mile stretch, and we also should preserve 6-mile stretch, because from those two cases, our net benefits are positive. So that is the cost and benefit analysis. This one is exactly the analysis for 6-mile stretch. Then we will talk about the concept of optimal level and efficient level. So efficiency in economics is defined as allocation of resources in a manner that maximizes total surplus. So as we can see, when we preserve 4 miles of river, then our net benefit would be exactly this area. If we preserve 6 miles of river, our net benefits would also be this amount. However, it is not the efficient level, because when marginal benefits curve equal to marginal cost curve. That means when we at this intersection, the net benefits are maximized. So when MB is equal to MC, we can say the net benefits would be exactly A, B, O, this triangle, and this one is greater than the net benefits when we preserve 4 miles of river or 6 miles of river. So we can say, yeah, we can preserve 4-mile stretch, but it is not an efficient level of preservation. So here is a brief introduction of cost and benefit analysis. Now, let's go to my next question. How can we compare costs and benefits over time? My intuition for this question is that suppose we are going to build a bridge. So first we need to calculate the cost, and then we need to calculate the benefits to find the difference between costs and benefits to see if the net benefits are positive or negative, right? But the costs and the benefits, they may exist forever, because if we are going to build a bridge this year, the project can be done. There would be labor fee, some maintenance fee this year, but for next year, the maintenance fee would still be existed. Also, 2 years later, there will still be some maintenance fee. 3 years later, still be maintenance fee. So how do we convert those fees back to today and calculate all those fees or benefits together to get the net benefits? So that's the key point of my question. For example, the value of $100 today is $100. However, if you took $100 and deposit it in the bank, the interest rate R is suppose it's 5%. What is the future value of after 1 year, which should be equal to 100 times 1 plus R, which is quite simple, right? This example. So in this example, we introduce the several elements. I can say first one is the present value, second one is the interest rate, the third one is the number of years, the last one is the future value. Let's see how we define present value and future value. So in this course, we define present value as the current value of a future sum of money given a specific rate. So we define future value as the value of a current asset at a specific date in the future based on an assumed rate. So let's go back to this example. The future value is defined as the value of current asset, right? So the value of current asset in this example is $100 at a specific date. The specific date is after 1 year. In the future, based on an assumed rate, the assumed rate is R. So the future value is depending on those three elements. 100 times 1 plus R, it is just the definition of future value. So for the present value, it is defined as the current value of a future sum of money given a specific rate. Suppose you will receive $100 after 1 year, and and we also assume the interest rate is still 5%. Then what is the present value? So present value is calculated by dividing future value by 1 plus interest rate. So in this case, it is calculated by 100 over 1 plus 0.05, which is equal to 95.22. So 95.22 is our present value, and our future value, the current value, is we call it the present value. A future sum of money is 100, given a specific rate, which is R equal to 5%. So those two examples should help you make a difference between the future value and the present value. So here is the formula to calculate the present value of a one-time benefit, FV, after n years with interest rate R. So let me rephrase this sentence. After n years, you will receive a one-time benefit, and the amount of this one-time benefit is FV. The interest rate among those years is R. So what is the present value of this one-time benefit after n years with interest rate R? So here is the formula we can use to calculate the present value of this benefit, and we call this part the discount factor. Here is an example in Excel, and from this example, I hope you can understand the equation very well. Suppose the interest rate is 0.1, and suppose we are starting from 2019. So that means in 2019, n equal to 0, time period is our n. So the discount factor is defined as 1 over 1 plus R hat n. This is the discount factor. So the money received is the future value. The present value is just the present value. So in 2009, the time period is 0. Then the discount factor is equal to 1 divided by 1 plus R is equal to 0.1 hat time period. So discount factor is equal to 1. The future value is 100, because you will receive 100 in each year, and then you need to convert the 100 back to 2019 dollars. Then the present value is equal to FV times discount factor, which is clear, right? It's 2009. For 2010, the time period is equal to 1, since the difference between 2010 to 2009 is 1, right? The discount rate is equal to 1 divided by 1 plus R hat n, and the future value would still be 100. Then the present value is equal to future value times discount factor. So all I do within this table is the process to calculate the present value, depending on time period and depending on discount factor, depending on money received in the future. So the first one is the n in our equation. The second one is just this part, discount factor, and this column is just the future value. So I hope this example would be clear enough for you to utilize this equation. And if you are still confused about make a difference between present value and future value, here's one more example. Suppose your grandmother gave you a certain amount of money when you were younger, and you cannot really remember how much it was. All you remember is that you put it in the bank at an interest rate of 5% per year for 7 years. And after 7 years, you have $100. So my question is, how much do you think your grandmother gave you before it becomes $100? So try to use this formula to calculate how much do you think your grandmother gave you before it becomes 100. So in this example, our FV is equal to 100. Our R is 5%. N is 7. So you already have all three elements you need to calculate the present value. So it should be very clear, and understand how to do this kind of question is very important, because you may have the similar or exactly same question in your assignment or exam. So the next part is critical for the cost and benefit analysis. So as I talked before, when we are going to undertake a public project, or when we are going to do any decision in economic perspective, we need to do the cost and benefit analysis. So that means we need to find all kinds of benefits related to this decision or this project, and then we need to find all benefits related to this project. Then we just take a difference to see if the difference is positive or negative. So if the difference is positive, we can feel free to go ahead to undertake the project. If the difference is negative, then the project may not be good enough. That is the cost and benefit analysis. However, there are so many criticals. First, there are so many uncertainties. For example, the benefits. The benefits may come from different aspects. For example, it can be additional income, it can be an increased quality of life, or it can be a cleaner environment. So it is hard for us to find all those benefits related to a certain project. And on the other hand, even though we can say that due to this project, there would be an increased quality of my life. But how do you value that? Even though you can say the air quality becomes better, the water quality becomes better, but it is very hard for us to value the cleaner air or the cleaner water, right? So that's what I say. There are so many uncertainties related to the benefits. Also, the costs. The costs may also come from so many perspectives. For example, some opportunities, some internal and external costs, and also some pollution externalities, some tax externalities. First, it is harder for us to find all those costs. And second, even though we can find all those costs, but how do you value the pollution? And remember, we talked several methods, like the survey method. We can value the willingness to pay, willingness to accept the pollution damage, and also we can use reviewed preference method. But all those methods cannot provide the exact value of the environmental good or service, because there are also some drawbacks of those methods, right? So that is the uncertainty part. And second, we need to find an approximate social discount rate. When the public project becomes true, we cannot simply use like 5% in our example or 7%, something like that. We need to take the social discount rate into account. So if the discount is so large, so for example, if you discount greatly, that means $100 worth much less in the future. So that also means you may want to spend $100 as soon as possible, because it worth much more today. The 100 bill worth much more today if you discount greatly. So if you don't discount at all, that means there would be no difference between spending $100 today or tomorrow, right? So the social discount rate is very important. It affects the value of costs and benefits. That is the social discount rate. Then we will talk about distributional concerns. So that means the costs and benefits of pollution or of a public project or of a decision do not necessarily accrue to the same individual. So think about the pollution. The benefits of pollution first come from the producer part, because producers, they can get some profits from production, right? And also the benefits of pollution can come from consumers' part, because for consumers, they can also get the products from production process, right? But for the cost, the costs may come from the residents' part, because the residents, they suffer from the pollution, they suffer from the air pollution, or they suffer from the water pollution. So the groups of cost receiver or benefits receiver are different. So it is also another concern of the cost and benefit analysis. So that is all for this video. First, we talk about the definition of cost and benefit analysis. We review what is total costs and what are the total benefits. And then we make a difference between cost and benefit analysis and the efficiency or optimal level. The efficiency means that we need to maximize the total surplus, the total net benefit. But the cost benefit analysis says that when the net benefits are positive, we can go ahead to undertake the project. We don't really need to maximize the net benefit. So that's the difference from these two perspectives. And then we talk about the present value and also the future value. The 100 you have today, which is not equal to the amount of 100 you have tomorrow. So when we are doing cost and benefit analysis, the costs in the next year or the benefits in the next year, the amount is not exactly same as what we would have in this year. So we need to convert the future value back to present value. Then we do the cost and benefit analysis. So that is the key point of present and future value, why I introduced those two concepts. Because we need to convert the future value back to the present value to compare total costs and total benefits. Here is a formula of calculating the present value, which is very, very important. If you are still confused, feel free to message me or email me. I can record another video or find some other resource maybe helpful for you. And the final part is critical for the cost and benefit analysis. That's all for this video.